Well, greetings and welcome everyone to our special live presentation about observing from your campsite. I'm Mike Murray, astronomer and manager of the Delta College Planetarium in Bay City, Michigan. Well, it's that time of year again, time to journey into the outdoors. If you've tried to make any campsite reservations yet, then you've probably noticed how quickly the campgrounds and RV parks are filling up. Not surprising, given the added isolation we've been going through over the last year. There's also been a huge uptick, though, in telescope purchases. Interest in amateur stargazing is at an all-time high. And so we're going to take you through some of the tips and tricks for enjoying stargazing from your campsite. And so, first of all, let's take a look at what are the kinds of things you can see. If you're going to be out at a campsite, usually you're going to be in a site where you at least have access to some very dark skies. So let's just run through a quick list, first of all, of what are the things you might be able to see out there in a dark sky site. Well, for some, just getting out under an open sky full of stars in the Milky Way can be an awe-inspiring experience all by itself. You do not need to bring along some gigantic telescope. In fact, you don't need a telescope at all. We will show you some things that you can see with naked eye, binoculars, and a small telescope, but it's not necessary. There's lots of different levels that you can have fun with. For example, you can start just by looking for the brightest stars. That's going to be important because bright stars are your guideposts, your way of getting your bearings on the sky. Maybe you just want to trace out a few constellations. In fact, there are groups of stars, like the Big Dipper, that can serve as your good starting point, your guidepost. And we're going to give you some resources to help you with that. Other things you can see, especially in a dark skies, it's a good time to watch for meteors. What we sometimes call shooting stars or falling stars. These are really tiny pieces of rock, metal, or ice that burn up in our atmosphere. And on any good, clear, dark night in the country, you could see 5 or 6 meteors in an hour, what we like to call sporadic meteors. There are times during the year that there are what we call meteor showers, when the Earth is crossing the orbit of a comet and we sweep up millions of tiny little flecks of ice. And of course, one of the best known and one of the most reliable and spectacular is in the summertime. That's the Perseid meteor shower, which happens in mid-August. Other things you can see, of course, there'll be the moon and planets, and the planets particularly might look a little more spectacular, a little bit brighter, a little bit more noticeable when you're out in a dark sky site. And sometimes the planets and the moon will come near each other, what we call conjunctions, and that can be pretty spectacular. When you're out in the country, the International Space Station might be a little more noticeable. You could see it from just about any locations because any location, it's almost as bright as Venus. But if you check some of the websites ahead of time to see if it's going to fly over your location for the time that you're there, just a little something extra to keep in mind on your list. And then there's the northern lights, especially if you get up into the northern part of the lower peninsula or up into the upper peninsula. And there are websites that you can check ahead of time for aurora alerts to see if the northern lights might be active. We mentioned the Milky Way, and I'm going to emphasize that several times because it can be a really incredible sight from a dark sky location, especially when there's no moon. Plus, the summer Milky Way is brighter and more prominent than the winter Milky Way. We're looking more toward the center of our galaxy, so the concentration of stars is a little higher. Just remember that in early summer, you'll have to wait until after midnight for it to get high in the sky, but by late summer, the Milky Way will be up much earlier. What happens when we add some binoculars to the toolbox? Well, binoculars open up a lot more of the sky than you might think, especially if you're at a dark sky site. Going back through the Milky Way and scanning slowly with your binoculars, you'll find that it resolves into thousands of distant stars. And you might notice some faint fuzzies along the way. These are, of course, what some observers will call the deep sky objects. Things like star clusters, or faint little clouds of glowing gas called nebulas. Or even a comet if one happens to get bright enough. We were treated with actually more than one bright naked eye comet last year. If the moon happens to be out, binoculars can reveal some amazing detail, craters, mountains, and the dark colored plains called maria. You know, what makes up the man on the moon. The moon does change dramatically from one night to the next because of its orbital motion around the Earth, so it will change its position quite a bit from one night to the next, and that means it goes through its phases pretty rapidly. The best details to see are going to be near the terminator, that line that separates lunar day and night. That's where you'll see long shadows, which means you get to see more surface relief, some of the height features. Okay, so how can you locate the things that you want to see, especially when you're out where it's really dark and there are a lot of stars to choose from? Well, the golden rule is always start with something easy and familiar, like the Big Dipper. It can serve as a guidepost to other important stars and constellations. For example, the two stars in the end of the bowl are often called the pointer stars, because you can imagine drawing a line out of the bowl to draw you right to Polaris, the North Star. Now, don't let this chart fool you. Polaris is not the brightest star in the sky. It's like 47th. That's because Polaris is not important because of how bright it is. It's important because of where it is. It sits almost directly above the Earth's North Pole, and that's why it always seems to stay in that one place. In fact, the Big Dipper is useful for tracking down other bright stars as well. There are many mnemonics for some of these star hops, like follow the arc to Arcturus, and then spike to Spica, or spin along to Spica. I've heard it several different ways, but whatever works for you. Yes, there are phone apps that you can get that will overlay a map onto the sky as you move, but these will only work if you have cell phone coverage. And even if you do, it helps to gain some familiarity with the real sky so you can get the feel for how they translate onto the stars, whether it is a phone app or a star map. Now, maybe you've seen some of these star charts. I like to call them star dome charts. It's basically a copy of the whole dome of the sky. And there's another version that can be even more useful. It's called a planisphere, or some people call it a star wheel. And this is where, if you look around the edge, you've got the months and days, and on the inner circle, which moves, you can turn it around, is you've got the times of day and night. So in this case, it's like a dome chart, but it's adjustable. So you don't have to get a new dome chart each month. You just look and line up the time that you're going to be observing with the date, and this will be your sky. However, how do you use this thing? How do you apply it onto the sky? You don't lean back down on, say, the ground and hold it straight up. Even though that's supposed to represent the whole entire sky, you're only going to look at one part of it at a time. So you line this up, kind of like how the observer has it here. See, she's holding it up at just a slight angle and facing the direction that she wants. So if she's facing south, or you're facing south, then you put the southern horizon of the chart into the same direction you're looking outside. And then you're just going to look in this area, this quadrant, because in the middle of the chart, that's straight over your head, and anything back here is behind you. By contrast, if you want to look and see what's coming up out of the east, then take the chart and put the eastern horizon down at the bottom to line up with the eastern horizon out in front of you. So you just look at a part of it at a time, and you look for the brightest stars as your guidepost. And there are more bright stars than just the Big Dipper. We're going to get to that, especially for summer. I highly recommend that you prepare for an observing session by using the free computer software called Stellarium. It allows you to set up the date, time, and location so you'll know what's visible in any part of the sky. From there, you can devise some simple star hops ahead of time. That way you're not frustrated trying to figure it all out in the dark once you're out there at your campsite. You have a little bit of preparation. So stellarium.org, you can download that. There's a phone version of it as well as a desktop version, and they're free. So let me give you an example of how to do this. Here is a stellarium view of the summer stars facing southeast. Well, in May, right now, you'll have to wait until about 3 a.m. to see this. But the stars rise 2 hours earlier a month due to the orbital motion of the Earth around the sun. That means by mid-July, this will be your sky at 11 p.m., which is perfect because evening twilight ends so late at that time. Let's zoom in on this section where if you look, you'll see that there are 3 bright stars in there. Let's zoom up on that. These are among the 3 brightest stars in the summer sky. And because of that, they have ancient names going back thousands of years. The brightest of the 3 here is the blue-white star Vega or Vega. Deneb. By the way, these are mostly all Arabic in origin. And Altair. Well, of course, if you look at these 3 bright stars together, you'll notice by connecting imaginary lines that you get a giant triangle. The summer triangle. This is always the best way to begin your stargazing for the night. Something easy and recognizable. And for the summer, after you've located the Big Dipper, the summer triangle is one of the most ideal starting places. Each bright star in the triangle belongs to its own particular constellation, which if you want, if you like constellation hunting, you can use your star map to trace them out. Like Lyra, the harp, which contained Vega, or Cygnus the swan, sometimes called the Northern Cross, and Aquila, the eagle. If that's your thing, tracing out a few constellations, that can be a fun way of utilizing those bright stars. But remember, you can also use them for star hopping. And that's where we're going to get into a few observing tips now. Let's assume that you are out where it's dark, you're at your campsite. What do you need to know in order to get more out of your observing experience? All right, first step, preparation. We already mentioned things like it'd be nice to look at your charts before you go out, find the brightest stars, know what part of the sky they're going to be in, maybe even come up with a short list of objects that you want to look for. They don't necessarily have to be telescopic objects, just some interesting things that are coming into view. Make sure that when you're at your campsite, while it's still light out, see if a lot of campsites have a lot of trees, and that's great for shade, but at night you want to be able to get out in the open so you can get some lower horizons. So if you can locate something of an open field nearby, be sure to go out and check out the spot you'd like to observe from in the daytime. That way you don't accidentally trip over things in the dark once you're trying to walk around and get to that spot. Okay. Next step, something that I call, or everyone calls, dark adaptation. It matters immensely that you let your eyes get sensitive to the dark. Dark adaptation is more than just your pupils opening up. Wouldn't it be nice to be a tarsier like this? Have really, really nice big open pupils. But the eye works in more ways to light sensitize than just the pupils. There's actually a chemical reaction in your retina that takes at least 20 minutes to become completely sensitized to low light levels. And that's also why you don't want to use any white light of any kind after you've dark adapted. It does help to be well rested and hydrated. That'll help with your dark adaptation. And if there are any lights nearby, try to position yourself so trees or buildings are blocking them. And one last thing, if you are going to be going out into an open field, then you probably won't need to worry about your campsite or campfire. But if you are staying near your campfire, be sure to let it burn down low so that the light isn't too bright and ruining your night vision. Next one has to do with that night vision, that sensitivity. If you do choose to need to read star maps or find equipment in the dark, always make sure you have a red filtered flashlight. In fact, make sure that it's deep red, because that will tend to preserve your night vision. You can do that by just putting a red filter in between the lens and the light bulb in a regular flashlight, or you can even buy them that way in many cases. Now, in order to see more detail, remember, you're going to be out in the dark. Things are going to look very faint in many cases. Galaxies or nebulas, even some star clusters will look very faint. Use a technique called averted vision. This is the art of looking slightly off from the object, but you keep your attention on it, like your side vision, your peripheral vision. And you might then, because your peripheral vision is more sensitive, you'll see more details eventually flicker in and out of view. So take your time. Speaking of which, another word for that, patience. Because it does take time for the details to build up in your eye. Your retina is not exactly the same as a camera, but it does have some similarities in that more and more of the little rods and cones in your retina will get sensitized and excited and enabled, if you will, over time. So you'll see more detail the longer you look and the more averted vision you use. So remember, you're not in a well-lit room looking at a magazine where the details leap out immediately. You want to take your time and let the details build up. Remember, these are photons that have been traveling thousands, if not millions of years to reach your eye. You're seeing the actual photons coming from that object, and they can be faint. All right, so these were the observing tips that I want you to remember: the preparation, dark adaptation, using red light in those low light levels, averted vision, and taking your time. And these are sketches. All of these are sketches from people who were using their unaided eye, either through binoculars or telescopes, not a camera, in order to try to see details. So let's start with an observing aid. Most of us have binoculars, and it would be highly recommended that you at least bring binoculars with you. They will show you many things that people think require a telescope. Handheld binoculars you're going to notice, are always hard to hold still, even small ones. A standard tripod can work well for looking at things near the horizon, but there are these parallelogram mounts, which can swing up and down and allow you to see more of the sky much more comfortably. And also, you can adjust them up and down for people at different heights, and it'll stay pointed at that object. Another option is to use a lawn chair, one that has armrests. This way you've got your elbow stable, and you can take the eyepieces of the binoculars and rest them on the bones underneath your eyes. That'll really help keep it still. Some people have come up with some pretty creative methods that use both. All right, so what about planets? Jupiter and Saturn are going to be up this summer. Right now, they come up in the southeast well after midnight. But that'll be earlier and earlier, remember, as the summer goes on. In binoculars, even Jupiter will start to show up as a disk, and you should be able to see most, if not all, of Jupiter's 4 largest moons. Now, I often get the question, what about the rings of Saturn? Well, you really won't be able to see the Saturn's rings in binoculars unless they're the giant binocs, like 25 by 100s. You'll need probably at least a small telescope and about 30 power. We'll get to that. If you check online or in the magazines to see if there's any comets visible, most of them never get bright enough to be seen with the naked eye, but a few times a year they can be seen in binoculars. With the help of a finder chart and a moonless night, you can often star hop to find one in your binoculars. Most will look like faint fuzzballs of light due to the sublimation of gases from their icy nucleus. Occasionally, one gets active enough to sport a tail, which is the dust and gas pushed away from the comet by the solar wind. All right, we mentioned the Perseid meteor shower is one of the highlights of the summer. It's just one of several meteor showers, but the Perseids are so well known because they have so many meteors per hour, anywhere between 60 and 100 meteors per hour if there's no moon. And what you do is, the peak is about August 13th, but they'll begin at the end of July. Look toward the northeast, especially later at night after 11 p.m. And you'll see that meteors are coming out of the northeast. They can appear anywhere in the sky, but they seem to radiate from that general direction. Well, while you've got your binoculars, you don't want them during a meteor shower. You want to take in as much of the sky as you can. But in between, maybe take a few minutes, there is a famous deep sky object right near the radiant point for the Perseids. It's below the W of Cassiopeia. And many times we call it simply the double cluster. The double cluster in Perseus is a fabulous sight, and this is what it could look like through binoculars. In a small telescope, it would look even better, it would fill much more of the field of view. All right, well, speaking of telescopes, what if you do have a small telescope, or you know someone that has one, or someone at the site has one? There are obviously a few more things that you'll be able to look for now. All of the things that we had listed so far, of course, put your telescopes on those, but some new other objects like double stars. And some of them have some beautiful contrasting colors. This is Alberio, the head of Cygnus the Swan. In a telescope, planets like Jupiter will show up as a big bright disk, and the moons will be much more obvious. You might even notice some of the stripes and bands in Jupiter's atmosphere. Remember, Saturn is not too far away. It takes only about 30 power or so to just begin to make out the rings. But they will be pretty clearly obvious if you've got a good clear sky and minimal haze low in the south where Saturn's going to be. Well, remember when we talked about star hopping? You can take star hopping down to an even smaller level, smaller space level, in order to find and locate objects for your telescope. So let's take an example of something that's visible in the summer. High overhead is what's called the keystone of Hercules. Kind of looks like a trapezoid for those of you who are mathematically inclined. Well, in the keystone, you'll be wanting to point your telescope to a very specific spot, and it's right here. This is the location of a very well-known deep sky object. Charles Messier, in his catalog, recorded it as his 13th object, but it does have a name. We're going to get to that. So your star hop is look for the keystone, looking high in the south, almost directly overhead, and look for the star in the upper right corner. Now imagine if you could draw a line down to the lower right corner. M13 is almost right in that line, about a third of the way down. That is where you would put the crosshairs for the finder scope. And at low power, it'll appear as a faint little circular smudge of light. You might even notice it like this in binoculars, just very small. In a small telescope, you should be able to resolve it into thousands of tiny stars. This is where patience, dark adaptation, and averted vision come into play, because the longer you study it, the more it resolves into a ball of stars. M13 is more commonly known as the Great Globular Cluster in Hercules. This is a medium telescope view at high power. The cluster is still a part of our galaxy, but it's 25,000 light years away, orbiting in a halo around our Milky Way. It has maybe 300,000 stars in it and is estimated at nearly 12 billion years old, some of the oldest stars in our galaxy. Summertime is a good season for looking for globular clusters, but there's a lot of other objects that you can see in a small telescope or binoculars, especially if you were to look low in the south later at night for the bright part of the Milky Way. You notice how it's getting brighter and wider as you look lower into the south? You'll have to wait pretty late to see this now, but remember later in the summer it'll come up earlier. Well, back to Stellarium. Looking down there, you'll see that there are two prominent constellations down there low in the south. Let's highlight and zoom in on this. You see all those bright stars right there. Let's zoom up on that. This will be your view looking south at around 1:30 a.m. in June, 11:30 p.m. in July, or 9:30 p.m. in August. Remember, the stars reach the same position in the sky 2 hours earlier a month due to the seasons. First of all, look for a group of stars that's shaped kind of like a hook. This is Scorpius, the scorpion in Greek mythology, but it's been seen as many objects, like Maui's fishhook in the Hawaiian Islands, while other Native American tribes saw it as a snake. The other one, well, it's called Sagittarius, which is supposed to be a centaur, but looks more like a teapot. In fact, not all the constellations bear a good resemblance to what they're named for, so if you need to make up something easier, by all means do it. What matters is getting the stars that you need. It doesn't have to look like what it's named for. So this is Sagittarius, the archer. Yeah, he's supposed to be a half-man, half-horse figure. Good luck. But if you look above the spout of Sagittarius's teapot, it looks like there's a puff of steam over there, if you will, a smudge, a detached piece of the Milky Way. Well, on a clear, moonless night, you should be able to just barely notice it to the naked eye. This is the Lagoon Nebula. And this is the view in a medium-sized telescope. It's a huge cloud of glowing hydrogen gas where stars are forming. That section of the Milky Way, by the way, that whole stretch down there in the south, is full of objects like nebulas. Here's another one. If you were to follow up the Milky Way, up and left from the lagoon, you'd eventually come to this. what's called the Swan Nebula, another star-forming region that shows up nicely in a small telescope from a dark campground. Just above the tail of Scorpius are some beautiful little open star clusters, like this one called the Butterfly Cluster. So even if you don't have a star map, just take some binoculars and scan nice and slowly through the Milky Way in the south. I guarantee you, you'll find some beautiful little objects like clusters and glowing clouds. Well, later at night, remember how we used the finder chart where we used the W of Cassiopeia as a pointer to find the double cluster, or also to know where the Perseid meteors are coming from? Well, later at night, if you were to move southward, you'll eventually find yet another faint smudge of light. On a moonless night, you should be able to just barely see it to the naked eye. That is the most distant object you can see in the sky without a telescope. In fact, it is a completely separate galaxy in space. It's like our sister spiral. And I'm giving you two images of it here because I want to show you how telescopes, different objective lenses, different sizes makes a difference. It's not about magnifying power. This is the same magnifying power, but in two different telescopes. This one is a very small aperture, maybe only a 3-inch telescope. This is exactly the same magnifying power, but in a 6-inch telescope. So it's not about magnifying power, it's about how much light the binoculars or telescopes are gathering. Okay, let's sum up a few things. First of all, the first rule of observing is to be comfortable. And so make sure that you can be well prepared for stargazing, because even in the summer, it can get kind of cool at night. So be sure and bring layers. Layers of clothing are good because if you do happen to get too warm, you can always just peel some off. You're going to be standing for a while, especially if you're going to be looking, standing to look into the eyepiece of a telescope. So have comfortable shoes. Yes, we all know what Michigan is like, especially after sunset, so bring that insect repellent. Drinks, especially warm drinks, can be helpful. Don't forget your star charts, maybe a list of objects we talked about. Make sure you have some of those lights that are red filtered. I like some of these kinds of lawn chairs, the zero gravity chair. They can be very comfortable, because if you just want to lean back and take in the sky or watch for meteors, satellites, whatever, those can be really comfortable. If you do take some star charts with you that you want to read, you can bring a small light folding table. And of course, don't forget your observing instruments if you want to bring some along. We talked a little bit about some of the constellations. If maybe you just want to go out and lay in a chair and talk about star stories, there are sometimes telling ancient folklore of the stars can be really a lot of fun. And there are some good sources. These are just a few. And I like to list this one here for the native sky watchers, because the Native Americans in particular had a very rich lore about the night sky. Many contain life lessons. There are what are called dark sky preserves in the state of Michigan. Many other states, I believe, have them now as well. It's quite a growing thing. And these are just the few of the many parks, but these are the ones that have designated dark sky preserves at them, which means they have observing areas within their boundaries for dark sky viewing and no lights. And there is a shortcut for the website that will give you more information about those. In addition to Michigan's dark sky preserves, we also have what the International Dark Sky Association calls the International Dark Sky Parks. these have much, much more stringent guidelines in order to be certified as a place with exceptionally dark skies, but they are also designated because of their nocturnal environments that are protected for their scientific, natural, and cultural heritage, educational. So they have a lot of purposes and uses. There are two of them now in Michigan. The Headlands, located up at the northwest tip of the Lower Peninsula, west of Mackinac City, that was designated in 2011. It hosts all kinds of programs and has a new event center. Whereas the newest park in Michigan, the Dr. T.K. Lawless Park in the southwest part of the Lower Peninsula, became a certified dark sky park in 2019. Their grand opening events were delayed due to the pandemic, but they are excited to get them back onto the schedule soon, so be sure to check their website. You can get information on these and all the parks around the world that are on this website, because there are actually now over 100 international dark sky parks on 6 continents. However, there are regional observing events called star parties. These can be collaborations between astronomy clubs, the national parks, museums, and planetariums. There are usually multi-day and night events that can draw hundreds of people, all camping out to share the experience of stargazing. You can get a lot of great advice here and experience from folks who are all too happy to share. In fact, it's a great family activity. You can get your camping, they'll have special guest speakers, and the only thing that will get you in trouble with these folks is if you turn on a white flashlight. Dr. Jekyll, Mr. Hyde situation. So yes, make sure you remember your red flashlights. Always ask before you look through somebody's telescope. You know, everyone just loves to share the hobby. It's a very, very rapidly growing situation. In Michigan, it's known as the Great Lakes Stargaze, located in the central part of the state, north of Midland, and takes place nearest the new moon in September. But whether you're at a star party, or by yourself, in the wilderness or in your backyard, go out and look every chance you get, because even if it's just for a few minutes, it'll improve your skills for when you get that ideal site, those ideal conditions. And again, remember to make it a family affair. All right, well, I want to thank you all for joining us. And please feel free to check out our many resources for sky observing. We have them not only on our website, we also have our own YouTube channel with an extensive series on the constellations and other objects. And we have a podcast as well. All of that is available there.